Hello, today we were going to talk about 8-bit counting, and this is a method of memorizing our binary values and decimal values with the first 8 bits. In this case, the first bit represents the decimal value of 1 using the 2 to the 0 system. And as we move to the left and add a bit every time, we get to this number, which is 128, represented by 2 raised to the 7th power. A way to think about that is 2 multiplied by itself 7 times gives us 128. Now, what this is a way that we can use this fundamental method of counting, and it helps us work out the solutions in all types of networking problems and computer science problems, whether it is IPv4 or IPv6, whether it's decimal counting or hexadecimal counting. The computer stores this information in a binary form, and it represents data in this way. So, like I said, each one of these represents a bit. There are 8 total bits here. 2 to the 0 is 1, it's the first value. And if you think about this particular value, we know that if we have a bit, we can represent this bit in 2 states, 0 and 1. When we want to add a bit or go over to the number 2, we actually have to flip this bit to 0 and then add our second bit. So this is the number 2. And then we have the number 3. We've added a bit here. Now, when we want to add one more bit and go to the number 4, we have to set these bits to 0. And again, we're going to put our 1 right here. This 1 is representative of the state that equals the number 4. So this number, as we go to the left, is indicative of the first value that when we flip the bit, all the other bits go to 0. The 128 bit in this case is 1. And then we continue to count using this method, continuing on the other way. That's why the total number of values that we could represent here, including 0, is 256. The total decimal values that we can represent with all this is 255. So if we sum these things and we start with 128, we know that we can have all the rest of these values can sum to 127 if they're set. That gives us a total of 255 values. Now this is pivotal information when we're doing net masks and net wildcards as well. That's a more advanced networking topic. But I want to show you one other thing in terms of this 8-bit counting and what this represents. When we look at this process right here, and we split this right down the middle, we split it right down the middle here. And we have the first 4 bits that we use. This represents the hexadecimal possible value of F is the highest possible number we can get to in this half, and F is the highest possible number we can get to on the other half. So what we end up with right here is FF. That is another way to represent, in this case, all of our binary values being set. This is also one component of the IPv4 address. There are 4 of those. So this 8-bit counting is what we would use to form each, what's known as an octet. In the IPv4 address world, this is one of those. So half of that 8-bit number, 4 bits, is one hexadecimal value. The other half is the second, and they combined to form an octet. In IPv6, we will use these and combine another one of them to produce a hextet. So this is the basic form of counting that we use. Okay, so when we have these values, this actually works also in net masks. And when we look at the first value that we have in a net mask, which could be 0, that represents /24 network, but it also represents that every available host is there in that network segment. So 0 will be the first value we could see in a net mask. The next thing we would do is cut that network in half. We can use the 128 value. That's this bit right here. That's its numeric value. The next thing we see is when we continue toward making a net mask, is we continue to add bits to the right. So we can use 192. That is the sum of these two bits. And then the third number is 224. Then we can continue adding 240, 248. We added the 8. Now I'm going to add the 4. That's 252. And then I'm going to add the 2, 254. And then I'm going to add the 1, 255. So these are all the possible values that could be in the net mask. Now, there's no way necessarily to have any other values in this net mask besides the ones that you see in these 8-bit counting systems. So this is a way that you will be able to, you want to practice this, you want to write these numbers down, you want to memorize this 8-bit counting, because we can use these numbers to do many things we want to do with networks and network information. Thank you for watching the video today on 8-bit counting.